Yeah, guys. Open shortest path first. It's a open standard protocol. Earlier, what we discussed, EAGRP, Enhanced Interior Gateway Routing Protocol. It's like Cisco proprietary protocol. EAGRP Cisco proprietary. Now OSPF Open Shortest Path. It's a open standard protocol. It will work entire and all the vendors, different vendors like HP, Aruba, and all the vendors. It will be work. It's a open standard protocol, and it will be used like protocol ID is 89, and EAGRP will use protocol ID 88, but OSPF will use protocol ID that is 89. With the help of protocol ID will verify, will identify the service from coming to the upper layer, means transport layer. And EAGRP, having the EAGRP RP protocol ID is 88, and will identify the service from coming to the upper layer with the help of protocol ID. And OSPF mainly, that it is a link state routing protocol. OSPF is a link state routing protocol. Yesterday we discussed what is link state routing protocol and what is the advanced distance vector routing protocol. Means distance vector routing protocol will, if any changes occur in routing table, we have a router 1 and router 2, they are connected likewise, and router R1 having hundreds of prefixes and R2 having 100 of prefixes. If any changes occur in this routing table, here we have 100 prefixes. In these prefixes, some prefixes went down, some 10 prefixes are went down. So in routing table, in this R1 routing table, topology changes occur. In this routing table, topology changes are here. A routing table changes are occur here. So the link state, whichever the changes occur, that only will send the neighbor. But in distance vector routing protocol, it will be send the entire routing table. If here we have 100 of prefixes, then it won't send only this changes of prefixes. If 10 prefixes changes occurred here, in this link state routing protocol, it will be send only these changes. But in distance vector routing protocol, it will be send the entire routing table, and periodically it will be sent every 30 second. Every 30 second it will be sent entire routing table. But in link state routing protocol, whenever the changes occur, that time only it will be sent. So here CPU utilization is very less. CPU utilization is very less in this link state routing protocols. Now coming to the distance vector routing protocol. In distance vector routing protocol, whenever the changes occur or not, it will be sent every 30 seconds. So that is a disadvantage. And in link state routing protocols, there have like this is a router and one more router and one more router and one more router. Now coming to distance vector routing protocol. It's a distance vector routing protocol. In distance vector routing protocol, R1 having routing table, R2 having her own routing table, R3 also having own routing table, and R4 also having routing table. How will check routing table? Show IP route. It's a global routing table. Show IP route with the help of routing. We'll check the routing information. Now coming to distance vector routing protocol, they're having only their neighbor information. The distance vector routing protocol, the routers having only their neighbor information, not this kind of router. Topology information they don't have. But in OSPF link state routing protocol, here we have IS and IS, intermediate system. This is also link state routing protocol, and OSPF also link state routing protocol. These two routing protocols work in link state routing protocol. This link state routing protocol having entire topology routing information. Entire topology routing information. But now coming to distance vector routing protocol, those routers having only the neighbor information, not for the entire routing table information. Now, even though we'll communicate with the help of R2 or R3, with if this is a destination IP address and this is your source IP address, source wants to communicate in distance vector routing protocol, it will be sent likewise. Will communicate, but R1 don't have the routing information, but R2 have R4 information. With the help of R2 via will communicate. But now link state routing protocol, their routing having the entire topology information. Entire topology information. That is the reason so it is hierarchical design. So here we have the area concept. That is the reason in OSPF we have the area concept. Those in area only entire, if here we have the multiple areas, those many router information we have in OSPF. If that is different router, then that is the another topic I'm telling. This is area 1, you can assume, and this is the area 0. Area 0 having their own routing table, own LSS, and area 1 having their own LSS. But in area 0, how many routers they have? Each and every router, those routers having their own area information, entire routing information. Now coming to distance vector routing, distance vector routing, their only neighbor information they have. I hope everyone got it. What is the difference between distance vector routing protocol and link state routing protocol? It's interview question. If you are not understand, ask me again, I will repeat it. It's important question. What is the difference between link state routing protocol and distance vector routing protocol? First thing is they will send in distance vector, they will send entire routing information. When any topology changes, any neighbor went down, any prefixes went down. But in link state, whichever the changes occur, that information only they will share. Every 30 seconds they will share in distance vector. But any changes occur, that time they will share, send the information in distance vector. So here CPU utilization is less. In distance vector, CPU utilization is more. Again, in distance vector, the neighbor routing information only they have. But link state routing protocol, entire topology information they have. Those are the differences, main differences. Any queries? Yes or no? No, sir. Okay. Fine. Now move to the actually OSPF uses the shortest path first algorithm, and we call it as a shortest path first algorithm, Dijkstra algorithm. Call it as a Dijkstra algorithm. It uses Dijkstra algorithm or SPF algorithm, shortest path first, SPF algorithm. It uses the calculate the best path for selection, the best path for select the path to the destination routers. From source to destination, it will be calculate the best path with the help of SPF algorithm. That is Dijkstra algorithm. And OSPF calculate metric as a cost. Here OSPF uses the cost. It is a metric. How it will be calculate? The source bandwidth by reference bandwidth. OSPF is a cost as a metric for the calculating the shortest path. The cost is a based on the bandwidth of the link. It is a cost is nothing but again, and some formulas will like cost is 10 to the power of 8. 10 to the power of 8 by bandwidth. Which bandwidth? Link bandwidth. 10 to the power of 8 by link bandwidth. And otherwise we'll calculate like it is interface bandwidth. Reference bandwidth by 100. Reference bandwidth is equals to 100 by interface bandwidth. And all the interfaces having the by default bandwidth, that is ethernet having the ethernet link having the bandwidth, that is 10 mbps, 10 mb. And f ethernet, fe fast ethernet having the bandwidth is 100 mbps, 100 mbps. And 1 gig having 1 gig having the bandwidth is 1 gb, 1000 mbps, 1000 mb. Based on like we'll calculate. And serial interface, one more serial interface also we have. Serial also we have, that is having bandwidth like in kbps 1.5 something, 1.5 some mbps we have. This is a bandwidth by default bandwidth we have. With the help of we'll calculate it. I'll show you in that in lab, otherwise I'll show you in. This is a by default bandwidth. Any doubts? No, sir. Fine. I'll verify in lab those things. Now, OSPF actually uses multicast IP address 224.0.0.5 for all routers and 224.0.0.6 for a DAR and BDR router. Just now write it. I'll show you. We'll discuss in depth for this. What is DR and what is BDR? We'll discuss these things. But whenever the updates, it will be sent based on the 224.0.0.5 and 224.0.0.6. And 6 is used for DAR. BDR will receive the update with 5 and they will send update through this multicast IP address. They will receive, all the routers will receive 5 and only DR, BDR, they will send the updates with the help of 6. What is DR and BDR? Designated router and backup designated router. We will discuss. And OSPF will use the AD value is 110. OSPF will use the AD value, that is 110. What will do with the help of AD value? What is AD value? Anyone can explain.
It is administration distance. Like every routing has its fixed AD value. Based on that, we'll determine which protocol to use or which path to use before going to the metric section.
Okay, fine, good. And OSPF support multiple path to a destination network which allows for load balancing, and it will be used minimum 4 equal path or maximum it will be used 16 path. By default we have a 4 equal path. For default maximum path are 4. What does it mean? See, here we have a router R1 and 1 2 3 4. This is a 4 path and our destination is here. So from source, this is a source and destination. Whichever the cost is less, that path is first preferable path. If here we are using 1 GB and 1 gigabit, it's a gig port, and it's a gig port, and it's a fast Ethernet port, and it's a gig port. It's a FE fast Ethernet, and this is a gig, and here Ethernet port, and it's a FE, and there's also FE. Based on the calculation of cost, it will be elected the best path. So first preferable path is this one, and second preferable path is this one, and third preferable path is this one, because here we have a gig link and we have a 10. No, it won't, it will not. And this one is the, because Ethernet compared to fast Ethernet is having the less bandwidth. So it's a fourth path and this is a third path. It will be store up to 4 path, and it will be do the load balancing also based on the packets, based on the from source to destination. It will be do the load balance. If multiple users are try to communicate from source to destination, so then they'll use load balancing also. But if one path is goes down, then we have a second path. In it will be stored in database table. In EAGRP we have the 3 tables: neighbor table, topology table, and routing table. Here also 3 tables we have. One is neighbor table and database table, and one more routing table. In database table, entire every path we have. How many paths are available? Those many path, first path, second path are available. In EAGRP topology table, entire routing path we have. Here database table, it will be stored. First path, first best path, second best path, it will be stored likewise. Understood?
Yes, sir.
And it is a classless routing protocol. Link state routing protocols all are the classless routing protocols by default. They are the classless routing protocol. What does that mean? Classless means, what is classless routing protocol? What does it mean? Anyone can answer it. Yes, go ahead. Anyone can answer it. What does it mean? Classless routing protocol.
Prefix.
Yes, prefix. Give the full answer.
Prefix not required. It is right or wrong, I don't know.
Classless does will not carry the subnet mask, whereas classful
Yes.
will carry the subnet mask. And classless can perform FLSM and VLSM. Classful can only perform FLS.
Moreover, it also has the information regarding the routing updates too.
Yes. See, a classless routing protocol will carry the with subnet mask information, whichever 26, 27. It's a class with subnet mask information. What does it mean? 255, 255 is a subnet mask, right? If 25 means like 128, like it will be carried with subnet mask information. Now coming to the classless routing protocol, classless means it will be carried with subnet mask carry, and it will be without. It won't carry without subnet mask means whichever the by default subnet mask is there, that only it will be carry. Apart from that, if /25 /27, if likewise, it won't carry. It won't carry the with subnet mask. Classless routing protocol will carry the with subnet mask information. So yes, it will support VLSM and FLSM, fixed length subnet mask and variable length subnet mask. Both it will be support. OSPF will support FLSM and VLSM. Till anyone have any queries?
No.
And actually in OSPF, we have the area concept. As I mentioned, we'll discuss in depth, but with the help of area concept only, it will OSPF uses area to divide large network into smaller, more manageable units. Because OSPF will maintain neighbor as well as entire topology routing information. So if we don't have area concept, then here we will face on the LSA floodings. If we have hundreds of routers in this area, we have 100 routers, and here you can assume 100 routers, and here you can assume 100 routers. If all this 100 300 routers we have, 300 routing information means every router having the 100 prefixes. So 100 into 100, like 1 lakh. So 1 lakh prefixes and 1 lakh prefixes and 1 lakh. More, it is more complex network. So if we have here 100 routers only, those having the one here multiple routers having, if this router R1 getting the entire routing information, it is a hierarchical design. So some LSA flooding will be happen. LSA flooding will be happen. So that is the reason here in this OSPF we have a area concept. So that is the reason only. We'll stop LSA flooding with the help of area concept. What is the requirement of area concept in OSPF? What is the requirement of area concept in OSPF? To stop the LSA flooding. Simple answer. To stop the LSA flooding. How it will be established in LSA flooding? If we have the multiple routers, every router will maintain neighbor information as well as topology router information also. It will be maintained R1, not only neighbor information, neighbor routing table, it will be carrying entire topology information. So that is the reason LSA flooding will be happen. So that is the reason we have a LSA area concept in OSPF. This is all about the basic things. Anything miss? And OSPF router exchange information about the network using link state advertisement. Each router send out LSA to information other router of its links and their states. What does that mean? See, with the help of LSS, whichever, see here we have a LSA, link state advertisement. Link state advertisement, whichever the information they have, routers having this R1 and R2, R1 and R2, both are sending hello packets. And I'll explain these things. Before that, I'll explain the base what is a link state advertisement. Both are sending and receiving the hello packet. After then, they will share their how many routes are available, how many prefixes are available, how many LAN connection are available. Those many share route prefixes share with the help of link state advertisement. LSA, what we call it is LSA, link state advertisement. Whichever the router R2 is sending, they're having their own prefixes, routing information. With the help of LSAs, link state advertisement, they will send and receive. Each router send out LSAs to inform other router of its links and their states. With the help of LSAs, they will share and receive the information, whichever they having the route information. With the help of LSAs only. Here we have LSA1, LSA2, LSA3, those things is an important thing. I'll explain end of the session. But whichever the information they are sending and receiving in OSPF with the help of link state advertisement, we call it as an advertisement. They will share, send and receive the information. And here we'll discuss now how the packet flow will be happen in OSPF. Before that, write it. Here we have the 5 types of packets. 5 types of packets. 5 types of packet. Type 1, that is hello packet, and type 2, that is DBD, database description. Type 3, LSR, link state request. Type 4, LSU, link state update. Type 5, link state acknowledgement. Link state acknowledgement. Here we have 5 types of packets. Hello packet and hello packet, DBD, LSR, LSU, LS acknowledgement, link state acknowledgement. These are 5 types of packets. And here we have the different types of states. First, down, init, two-way, extart, exchange. Here we have a down, init, two-way, extart, exchange, loading, full. And init, we call it as a attempt also. We call it as a attempt also. We have a 7 states. It will be pass the information through full state. We'll discuss how it will be happen. Both will discuss. First of all, router 1 and router 2, just we enable OSPF with the help of the command. Just in R1, let's listen properly. R2, here we have R1 and R2. In between, we are using OSPF. Just we enable in R1 with the help of command R1 config, then router OSPF and process ID, anything. Process ID means it's under area or under organization, it will be work. It's under organization. Every organization will use different process IDs. Even if the process ID mismatch, also neighborship will be established. In yesterday, what we discussed, EAGRP need a here AS number. The AS number must match. If AS number is not matched, then both router not establish the neighborship. But here it will be established the neighborship. First, we enable with the help of router OSPF 100. Then we'll advertise with the help of any network command. Network with the help of network command. We'll advertise the prefixes whichever directly connected prefixes will advertise. Then once we enable here, first down state, what will happen? One side we enable, other side we have not enabled. One side we enable the routing and we advertise with the help of network command, whichever the directly connected. And one here and 1.2.1.1.2. We advertise with the help of this network command. Sorry. 1.1.1.2. We advertise prefixes, then neighborship not established. Only one side we enable, other side we are not enable. Then they are discussing like, hello, send with router ID. They are saying means for one side we enable, other side we haven't enabled. So that is down state, and both end we enable. First hello packets they are sending. It won't, if you enable here, then it will be, otherwise the hello packet still drop. Every 10 seconds it will be drop. Send the 10 seconds. Every 10 seconds. 4 times it will be sent. Hello timer is 10 seconds and dead timer is here 4 times of hello timer, then 40 seconds. If it will be wait for 40 seconds, if 40 seconds he don't get any OSPF packets or hello messages, then simply discard the packet. No neighborship. The hello timer is 10 seconds and dead timer is here 40 seconds. In some cases, we have hello timer is 40 seconds at broadcast network, non-broadcast network, and dead timer is 1. Then 4 times 40, 40, 80, 160. 4 times of that. Hello and dead timer. Then hello, if we enable both end, then it will be moved to the init state. Then it will be give the reply down to init. Then they are like asking, what they first he will ask like, hello, send with router ID. Once we enable both end, then the neighbor the R1 is asking, send me your router ID. In this router ID, first of all, we should have to manually configure. First of all, we should have to manually configure. If manually not configured, 2 types, manually, otherwise it will be elect dynamically. If we configure manually with the help of router command, with the help of router ID command, it will be elect that router ID only. If we not enable, then it will be elect based on the first, it will be moved to the whichever the we configure loopback IP address. Whichever the highest loopback IP address, it will be elect. If loopback is not there, whichever the highest physical IP address in this interfaces. If this router having multiple physical interfaces, here we have 11.1.1.1 and here we have 10. Here we have 192.168. In between, whichever having the highest prefix, that will be elect. Here we have the highest prefix is 192. Then it will be elect router ID as a 192. If we not configured manually router ID, then it will be moved to the loopback. Then it will be moved to the highest prefix IP. That is router ID. And both router will share in router ID. And some criteria also we have here. If we configured, then we'll receive. Otherwise, it won't send the neighbor information. If we not configured, then it won't send. Hello not received. If when we configured both end, then only it will be sent. If it is simply, it will be give reply hello not received when that neighbor is down. So some neighbor criterion, some neighbor information should be have. What it will be? Subnet mask should be matched. Both and subnet should be matched. If both are in same area 0, then area must match. If we configure authentication then authentication must match. If we are using password Cisco here, both ends password Cisco must match. If we are using router ID here and here, then router ID should be different. Both routers having should be different router IDs. If both having same router ID, then also neighborship will not form. Hello won't send. This everything should match, then only the routers will send and receive the information. And now move to the init state. In hello state, anyone having any doubts? Hello. Yeah, hello neighbor. And these are the neighborship parameters. These are the neighborship parameters. Now router ID must not match, area must match, authentication must match, subnet mask must match, hello and dead timers also match. Whichever we are using 10 and other also 10. Then only neighborship will be matched. And MTU size, whichever the sending the packet, that MTU size is must match. Stuff flags, it is an advanced concept, but stuff flags also must match. These all are the neighborship parameters. This is the hello message. What it will be carry the content in that hello message. OSPF version, it will be carry, message type, it will be a carry, and router ID, it will be carry, and authentication, it will be carry, subnet mask, it will be carry, hello timer and dead timer, it will be carry, entire information, it will be carry. Any doubts in hello message?
No, sir.
Once we enable both end, then they now move to the init state. In init state, they will send router ID and hello receive with neighbor router ID. means in init state. Now move to the init state. Here init state. R1 and R2, they are connected, and R1 sending the router ID and R2 also sending router ID. In router ID, how will configure it mainly? First, router manually will configure router ID and highest loopback IP address. If we not configure this one, then highest loopback IP address and loopback address also not there. Our physical IP address, that it will be router ID, it will be sent. That will be elected as a router ID. If we configure here 11.1.1.1 and here we configured 1.1.1.2. If we have other interfaces also here, like any interface like 10.1.1.1, then election will be here happen. Then in this, which one the highest, that will be elected as a router ID. Here 11 dot is the highest one, then it will be elected as a router ID. Then once in init state, they both will send and receive the router IDs. This router ID they will send and receive in init state. Now move to the two-way state. In this two-way state, empty DBD they will send and they will receive. Empty DBDs, not in entire database description. Empty DBDs they will send and they will receive in two-way state. In this two-way state, empty DBD they will send and they will receive. And actually, in two-way state, one is elected as a DR router and other one is BDR router. BDR. Apart from that, other routers, DR other router, whichever DR other router are there, entire routers will struck in this area only. This is if DR router, you can assume this is BDR router. BDR router, this R1 is DR and BDR, and we have another router that is DR other router. This router will struck in two-way state. They will struck in two-way state. In OSPF domain, if router receive hello packet and in that packet is seen its own router ID, then that router in two-way state means actually, and in this state only, in two-way state only, DR and BDR election will be happen. What is the DR and BDR election? What does in two-way state only DR and BDR election will be happen? DR and BDR, what is designated router? DR designated router, BDR backup designated router. Designated router means master router, and this is a slave router. Slave router. Basically, the DR router will send entire. It's a master router. You can assume here we have a router 1, R1, and R2 and R3 and here we have R4. In OSPF, we have a priority. By default, priority is 1. Up to it will be 255. Whichever having the highest priority, that router will become the DR router. If priority by default is 1, then priority is tie, then it will be moved to the highest router ID. Whichever router having the highest router ID, that router will become the DR router. Whichever having the lower than this DR router, for example, this is 11.1.1.1 and 11.1.1.2, and this is a 3 and this is a 4. Means in this highest priority is 1 by default priority is 1. We haven't changed. If the priority is 0, that always the router won't elect and don't participate the election. If the priority is 0, we change it the priority from 1 to 0 to 255. If the priority is 0, that router will not participate in the area in the DR-BDR election. If the priority is 255, that router is having the highest priority. That router always DR router. That is the master router. Master router only will, it's a king of the router. It is a king of router. The router only send the entire topology changes. If any changes occur in topology, that router only send and receive. That router only will forward the entire topology changes. And highest priority having the DR router. And if priority is matched, then highest router ID. Here we have router ID is 11.1.1.1 and 11.1.1.2, 11.1.1.3 and 1.1.4. So the highest physical router ID is 4. Then this is a DR router and this is a BDR router compared to 4, and this is a BDR. How it will be elect DR BDR election, it will be likewise. Any doubts in election criteria, guys? Please.
No. No.
Good. Understood, right?
Yeah.
If you are not understanding any concept, just ask me. I'll repeat that thing because it's an important thing. Whichever I am explaining here, and whichever I am explaining, not in CCNA level, I am explaining above that, top of that. In CCNA level, just CCNA level, our topic is done already. Only they'll explain OSPF, the basic thing up to here, and we have the types of messages: hello, DBD, LSR, LSU, and we have the neighbor states, down, init, and two-way extract exchange and loading full, and these things only they will explain up to CCNA level. If the topic is interesting, we'll move forward. Understood, right? You are understanding the concept or not?
Yes, sir.
Okay, now up to two-way state we finished. Now extract. We have a fourth state is extract stage. So R1 and R2, they are connected. Likewise, in extract state, what will be happen? In this state, empty DBD is shared and sequence number shared, and MTU size negotiation will be happen, and master slave election, highest router ID, router with become master and initiate that database sharing. As I mentioned here, DR BDR election will be happen here. DR BDR election up to establish here, but in this state, DR, which one is the master router and which one is the slave router, election will be happen in extart stage. And here I mentioned like MTDBD will share, and in that MTDBD continues here also, MTDBD only. In this state, MTDBD, they are not sharing any routing information. DBD, database description, what does it mean? DBD, database description. Till we have a message 2 only. Till we are in message 2 only. But in extart state, still we are not receiving any database description, which doesn't mean we have 100 prefixes here. That is database description, 100 prefixes, information, routing information, whichever LAN information, they till not sharing. Here what it will be happen, master, which one, the router R1 and R2. Here we have a one more router R3. If this router is elected as a master router, then entire routers will send to him. Entire routers, whichever routers are there, with the help of which multicast IP address, with the help of 0.0.5, they will send. Once he received with the help of 6.224.0.0.6, with the help of this multicast IP address, who and all required, he will send, R1 will send the entire routing information, whichever the topology changes, whichever required the information, master router will send to slave routers. Master router will send to other slave routers with the help of 224.0.0.6. This multicast IP address he will send. This is a init state. Now move to the exchange. Once master and slave election done, once master and slave election will done, then exchange the information. Entire they will exchange the information with the help of multicast IP addresses. Understood? They will exchange the information. Whichever the routing information they have, they will exchange. In exchange state means they will send and receive LSA headers. In this exchange state, they will send and receive. What they will send and receive? Link state acknowledgement, link state advertisement, link state advertisement. They will exchange all the entire information. Link state advertisement. In that, what be content? In OSPF router, exchange information about the network using link state advertisement. Each router send out LSAs to inform other router of links and their states. Entire routing and entire advertisement, what they have, the prefixes, everything will exchange in this exchange state. Once exchange state will be happen, then loading state. Then that loading state, first they will send LSR, link state request for LSA. First, how it will be happen in exchange state. Exchange after, then which one? Loading state, in loading. Which states we have? Here, which messages we have? Link state request, link state update, link state acknowledgement. Once they are exchanging, if first, how they will? First they will ask, can you send me your whichever the having the prefixes, link state advertisements, Likewise, they'll ask. First, R1 will ask link state request, and this router R1 will ask likewise, and R2 will give the reply update. That is, we call it as a link state update, received updates. He will receive the updates. Link state updates. Link state, whichever he's asked to the request, he will give update for that, and he will give acknowledgement. He'll send like acknowledgement. Yes, I got your entire, whichever you have sent the prefixes, those will be acknowledgement. This is a messages. Again, received for LSR. Again, he will ask, this router will ask, whichever you have the prefixes, just share me. Then request, he will ask the request, originated the request. Then LSU, request LSR. This one is the link state request. Whichever the prefixes you have, whichever the link state acknowledgements you have, just send it to me. R2 asking. Then R1 is giving the reply. R1 is giving the update, whichever having the prefixes LSU. Update. Link state update, LSU, link state update. Then he is giving the acknowledgement. Who again, R1 is giving the acknowledgement. Yes, I have received entire your updates. ACK acknowledgement. Likewise, it will be process will be happen. Then it will be moved to the entire, the information will be in loading, it will be happen in loading state. This is the loading state. Then once loading state finished, then they'll move to the full state. In that full, entire routing information and router will always in full state only. Adjacency will originated in between. Now entire thing will be happen route full state. They will send and they will receive the information of entire thing. That is a full state. Finally, it is a full state. Any doubts still?
No.
Fine. Now move to the, here we have a types of LSS. Just I'm giving the brief introduction. Before that, types of routers we have here in OSPF. In types of routers we have. First one is backbone area, backbone router. All interfaces are in area 0, that is backbone, and internal, all interfaces are in non-backbone, that is internal, and ADR border router. At least one interface in backbone area and one interface in non-backbone area. That router is called as a ABR and ASBR router. What does that mean? See, this is, we discussed area 0. Here we have a area concept as I mentioned. This is these routers are connected likewise. This is the actually area 0. Area 0. Let's say area 0. This area 0, this is the actually this router area 0, we call it as a backbone area. This is, we call it as a backbone area, and this is the internal routers. Internal, these are the internal routers. Internal routers. This one and this one. This is the both are internal routers. Both are internal routers. And one interface is in area 0 and other interfaces like we have, this is the area, some different area you can assume. We can assume this is a different area. Area 1. Area 1. So in between ABR router, we call it as a ABR router. This is a ABR router, area border router. You can assume here we have another area also. You can assume this area again connected likewise. And we have a different area also. This is the area 2. So area 2 and area 1, they won't neighborship form. We need backbone area. We need a backbone area. In between, we need a area 0 concept we required. Otherwise, they won't connect. Area 0 is must and should. That is the reason we call it as a backbone area. Backbone. In between, if here we have a area 10 and here we have a area 11. In between, if area 0 is not there, then they won't communicate to each other. We need area 0. That is, we call it as a backbone area. And this router, we call it as a ABR router, area border router. We call it as a area border router. What about ASBR? ASBR, autonomous system boundary router. See, we have a here OSPF. This is the OSPF. And this is any EIGRP. EIGRP. In between, what router is there? In between. That is, we call it as a ASBR. ASBR router. In between, we call it as a ASBR router. The router where we perform the redistribution, that router is called as a redistribution. When we redistribute from EIGRP to OSPF and OSPF to EIGRP, we call it as a ASBR router, redistribution. That is the reason only, redistributed prefixes. This is the area concept. Understood?
Yes, sir.
Yes.
And here we have a LSA types. Once we will finish types of LSAs, we'll move to the lab. And here we have a LSA types. Type 1, type 2, type 3, type 4, type 5, type 6, type 7, types 8, type 9, type 11 also we have, but those we are not using. And even though we are not using type 6 also, we are not using type 6 also. And this is a multicast type here. Actually, multicast type. Sorry, this is a multicast type. Type 6 is a multicast type. The multicast type, that is the reason we are not using. But first one is router LSA, and then network LSA, and summary LSA, and ASBR summary LSA, external LSA, and this is a multicasting LSA, and not so stubby area external LSA. So I'll give a brief introduction and brief explanation. Router 1 and router 2. Every router having their own LSA. That is, we call it as a router LSA. If if we have multiple prefixes, hundreds of prefixes, this router having the LSAs, whichever the router having prefixes, that is we call it as a router LSA, their own router. It within a area, it will be happen within a area in router LSA. Now move to the link LSA. In between, how many prefixes are available? That is we call it as a network LSA in between LSA. Then now move to the, this is LSA 3 and this is the area 0 and area 1 is connected likewise. This is the area 1. Area 1 in between area 0 and area 1, whichever the router originating the prefixes, originating the route, that is we call it as a summary LSA. This is ABR originating. ABR router will originate. This is the, whichever the DR router will be originate these prefixes with link prefixes, which with link prefixes. This is the own router. This is having own router, and this is the originating the DR router. This is the originating for ABR router in between whichever the area 1 and area 0. If we have another in redistribution prefixes, these two are the redistribution prefixes. ASBR originating. ASBR router will be originate these prefixes. Where, see, EIGRP and OSPF and EIGRP, in between one router is there. This router will originate LSA4 and LSA5. And multicasting, leave it, and not store stubby area means whichever the LSA5 and LSA4, we filter these prefixes. We know not require those many. If we are receiving thousands of prefixes, instead of these 1000 prefixes, I'll use one default route with the help of filtering commands. Where in LSA, in this LSA 7, filter the LSA 4 and LSA 5. It will be filter these two things, LSA 5, with the help of default command. This is all about LSAs. Even this is the advanced topic. For just remember it, we have the types of LSAs: router LSA, network LSA, summary LSA, ASBR LSA, external LSA, and not so stubby area LSA. I hope everyone got it, the OSPF concept. Till what we discussed. If you have any questions, ask me. I'll explain it. Otherwise, we'll move to the lab. Till what we discussed. If you have any queries, ask me.
Sir, is there a specific condition when we use DR and BDR? Is it
See,
default?
okay. Fine. Understood your concern. Basically, when we are here, we have the network types actually. In OSPF, we have a network types. And here we have a broadcast and non-broadcast. These are the full mesh topology. And point to point and point to multi-point, broadcast. In these three types, we are not using DR-BDR. In this type, we are not using the DR-BDR. Will not use. Will not use the DR and BDR. In this network types, actually, in this network types will not use. But in these two types, full mesh topology only will use. DR and BDR. Okay. In these two network types only will use. By default, the network type is broadcast network type. By default, network type is broadcast type. B means what is full mesh topology? Router 1, router 2, router 3, router 4. Likewise. This is a full mesh topology. Now move to the point to point means router 1 and router 2 in between directly connected. This is a point to point connectivity. Here we'll not use DR BDR, but here we'll use DR BDR election, because here you can assume router 1, what is the requirement of DR BDR election? To reduce the LSA flooding. See, this router 3. If we have hundreds of router, if you can assume this is a R100, means we have multiple routers. So these routers, as I mentioned, each router we have the 10 prefixes, means 100 routers, 100 into 100. Likewise, this many routers we are getting, this many routes we are getting. So many LSA floodings will be originated. So we have to stop this many LSA flooding. So we have a DR BDR required. DR router only manage entire routing information. Who and all required, he will be only sent. Apart from that, routers, all other routers, this all other router struck in two-way states only. Two-way state only. Two-way state. In this two-way state, only they will receive the update, and whichever the required thing, they will communicate. The communication will be happen, but they will struck in two-way state only. But if any topology changes occur, DR will be sent. If DR is goes down, then we have the BDR will be elected as a DR router. He will get the promotion. BDR will get the promotion. They will handle those things whichever the DR earlier did. Understood?
Yes, sir. Like this is done by default, right? Like we don't have to assign something.
When you are using these two network types, when you are using these three network types, here no DR BDR.
Like we have to assign it in like packet tracer. We have to do it manually, or
Yes.
is it
By
by
default,
default?
it will be elect. By default, it will be elect the DR BDR. I'll explain that thing in lab.
Okay. Yeah.
So but when we are using this network type, that time it won't happen. When we are using this network type, then only it will be happen. Fine.
Okay.
Apart from that, anyone have any questions? Guys, if you don't have any questions, we'll move to the lab. Shall we move?
Yes, sir.
I'll stop this recording.